So, welcome to the stream. I'm Frank Boucher, your host, and for the next 1 hour and a half, we'll be with Anthony Bartolo. We'll be talking about what you will be talking about, Anthony.
A lot of crazy things. I used to be part of a team of engineers that would go out and test out services that Microsoft's going to launch on Azure prior to it coming to fruition. And it was a lot of partnering with companies, like organizations outside of Microsoft, in terms of the adoption of said technologies. And one of the stories we'll be talking about today is how we used artificial intelligence, so specifically custom vision AI, to understand what life jackets look like when people are in the water and are in distress. There was a lot of work done around that project, and so it is one of the bigger projects that we'll be talking about today. But what I'll be sharing amidst all the projects that we'll be talking about is not only how it was built and how the solution came to be, but also the codes, or the code itself, the code itself. I'll be sharing the GitHub repos for all the code that was created so that you can, so you can replicate and you can test. And the reason why we do that is because, the projects that we completed were done in such a way that we made the code open source for others to take advantage of. Now, of all the code that's out there, obviously there is no prohibited code or code owning to an individual. So all the databases and everything have been wiped clean. It's just the architecture of the code itself that's being offered up as open source. And it's done in such a way where you can plug and play it into other solutions. And I'll actually show a demo of how we take this drone solution for the Canadian Coast Guard that we built and how it's being applied into other solutions. And we'll actually walk through a demo of that as well.
Excellent. So today is an open discussion. You will be sharing very soon your screen, and we'll see that. But at any point when people have questions, they could go type it in the chat. I will monitor the chat because I know sometimes we can be focused in the code or whatever we're presenting. So we'll make sure to forward any question to you. And if for some reason people cannot follow until the end, or maybe the question pop in their head after, where is the best place to reach out to you?
So you can get me on Twitter. I'm at Wireless Life. I know it's a moniker that people, where does that come from? It's, I was part of the mobile industry a long time ago. In Canada, we have a company called Rogers Communications. I was there for 10 years. And when I started out my career in tech, it was there. And so I was very much focused on wireless. And we'll talk a little bit actually in this presentation today. So I've been on Twitters for the longest time. That's probably the best place. But the whole team, and there's the whole team that I work with, can be reached if you do the hashtag AZOps with your question. That will also allow you to ask questions of the team, not just myself. And then there's also the show that happens every Friday at 10 a.m. Eastern Standard Time, which is the AZ Update show. Frank's laughing because I'm giving a plug for my show on the Twitch stream. If you want to check that out, there's also a blog post that we share every week with all the details in terms of what we shared on the show, aka.ms/AZ Update Show. I think, Frank, you put all the URLs in the show synopsis.
Wait a minute, you're plugging your show. You're stealing my quote. Okay, bye, guys.
Bonjour, comment ça va? Je m'appelle Anton. You do French a lot better than I do. Yo hablo español, pero el francés no muy bien. Sí.
So yeah. So if you're watching that on video on demand, all the link will be in the description. In Twitch also, we'll put that after the show. Everything will be there, and the Twitter handle will be displayed in a few seconds as soon as we go sharing your screen. Your Twitter handle will be just under. And now that you plug your show, you need to invite me at your show so I could plug mine.
Definitely going to have you on the show. The biggest challenge that we have right now is the show is being put on with bandages and duct tape. And it's like we have to time it in such a way so that the equipment that we're using lasts for the period of the show. We've actually started to incorporate recorded segments into the show right now, which we had Pumla have a conversation with Shannon Kunin about VMware on Azure, and it worked really well. And so we're going to be doing more of that. So definitely open invitation for yourself to come on the show with a recorded segment if you want to interview somebody, or if you have something that you want to show. And that's every Friday at 10 a.m. Eastern time that we have the show, and it's recorded for everybody to watch afterwards too.
Cool. So let's go to your screen now.
Okay.
My little animation. And now you have your Twitter under.
There you go. So there's my Twitter.
Just under you.
Yeah, Twitter handle's there. I also have the hashtag. The blog that we write for is itopstalk.com. And then my GitHub repo, which has all my code sources for everything that's made available as open source for all the projects I was participated in. What I wanted to highlight first is in terms of technology, right? What I'm going to show you is not that long ago. It may date myself and Frank, because Frank's going to see a couple items in here and go, oh my God. But this is something where, not too long ago, this was computing, right? I would go to a destination, I would go to a desk, it would have this device connected, Commodore 64, bought at Canadian Tire for $150 was my first computer. And you'd have to go to it, you'd have to turn it on, you wouldn't log in, you just, boom, here's the OS, the basic OS, load your application, pole position, I'm a car guy. That was probably one of my first favorite games that was available. The mobile device was strictly a communication device. And, to date myself in terms of how long I worked at Rogers, the Zach Morris phone there was the Motorola 8000 brick phone. It would last 6 hours. It would store 30 numbers, and it was only voice communication. Now, the technology was a lot older, it was analog, what have you, so it did use a lot more battery. But for portability, and if you want to have longevity, you would have a car phone, as you can see below from the two individuals from a television show from the 80s. You have the phone plugged into the cigarette lighter so that you would have all-day communication. This was what technology was back then. And then this happened, right? A lot of people say, no, it was the iPhone. I'm going to argue tooth and nail that it was the BlackBerry. This was the first connected device that people would have in their hands and would receive email on a device. This device ran on a single AA battery. It would last 3 days. It was on a proprietary network, but the capabilities of just receiving email on your hip was so astronomical. People couldn't even fathom, oh my God, this is amazing. I can read my emails from anywhere I go. And at that time, email was the biggest thing in terms of communication. There was instant messaging, but it hadn't really caught on as of yet. So this was a big deal back then when it came out. Now, this is back in the 90s and early 2000s. And then we're way past that now, right? So in 2018, there were 7 billion IoT devices connected. IoT, as you know, Internet of Things, is the new, not even new, it's been around for a while in respect to getting devices connected to the cloud for ingestion of data and prediction of outcomes. And in 2020, it's estimated that there's currently 32 billion devices connected. Now, what's interesting is that you don't really hear IoT devices anymore. You just hear devices because everything is being connected, from refrigerators to light bulbs to cars. What is a device being connected? It's everything. What are they doing? It's all the information it's grabbing. It's all the, understanding, patterns and understanding, even on the edge, giving the ability for that device that's capturing all this information to have the capability to even understand what it's looking at, and then digesting that information and providing a result or an outcome back to the cloud, as opposed to providing just the raw data. It's estimated in 10 years' time, we're looking at 80 billion devices connected. So that means, everything is going to be connected. I've even heard of desks that are connected to the internet or to the cloud to understand when an individual is sitting at the desk or not. And if that desk is not being used, why is it not being used? And should it be assigned to somebody else because it's never being used? This is how crazy we've gotten in terms of connectivity. To add to that, with all these devices being connected, as mentioned, there's a plethora of data that's out there that's being made available. 80% of the world's data has been captured in the last 2 years, 80%. And that's because of connected devices. That's because of connected individuals, mobile devices that are connected. We have computers in our hands. I can connect with my mobile device. I have an Android device. I can connect to the internet. I can connect to my Azure portal. I can stop and start services. I can, if I wanted to, I can roll out my Bluetooth keyboard and I can code away from my device. The whole availability of, being trapped on the machine or being trapped at a computer, not even a laptop. You can do it pretty much anywhere, and it's crazy. But it is, ushering in a new era in terms of what do we do with all this data. And one of the conversations I have quite frequently is, hey, I have all this data that's coming in. I want to plug it into AI. I want to either make more money by predicting X, or B, save money by predicting X. And it's interesting because the fact that, you know, a lot of people that come to me is like, I just want to rub AI in my business. I know it's going to make me money. Or I'm going to rub AI in my business. I know it's going to save me money.
It's true that people say that.
It happens a lot, right?
Yeah.
How do I adopt AI to do
like
this?
That. Yeah.
Right. How do I adopt AI to save money? How do I adopt AI to make more money? I want to, you know, predict this. I want to predict that. And it's like, well, what are you trying to accomplish? Like, the fact that you just want to make money doesn't really fly. You gotta be able to do something with it. You want to be able to build upon it, right? Solve the first problem, or address the first opportunity, and then from there build to something else and build to something else. And that's, you know, my first story that I'm going to share right now. We sat down with the Missing Children Society of Canada. This is a team of 17 people that handle all the missing children cases from across Canada to, you know, assist in when a child is reported missing. They immediately get a report to say, okay, this child has been, you know, reported missing. Can you help us with the investigation work to find out, you know, what had happened with the child, who they were in contact with, you know, maybe the patterns of where they travel and all that. And they had come to us at Microsoft with an ask to say, hey, can you help us? Everything that we do right now is manual. We would love for a way just to capture the data in a digitalized format, so that, you know, they wanted us to build out a portal so that the law enforcement can go in and type in all the information to automate the process of capturing the information. And we said, let's take it a step further. What is the biggest challenge? Like, so if you're digitalizing all your information, what are you actually trying to accomplish? And their response was, you know, when a child is reported missing, it takes us up to 30 days worth of research to find out, you know, who the child was in contact with, the sentiment of the conversation, their travel patterns from around the districts that they live in, their communication patterns, you know, all that information. We have to do that all manually. So, you know, digitalizing the input or the capture of these children being reported missing would help out a great deal. And we, you know, responded back and said, how about if we automated the process that allowed you to capture the information itself, so that you can build out this dossier in, you know, instead of 30 days, maybe a couple hours. And they were like, could you do that? And like, of course, like,
yeah.
Right. It's a big game changer in terms of finding kids. So this is the only GitHub repo that I'm going to have that's different. It's aka.ms/HFM. HFM stands for Help Find Me. And that's actually the moniker that we used in regards to this solution. The solution was called the Child Finder Bot. And what we actually did, and this was, you know...
Give me just 2 seconds. I will change. We'll go in the corner.
Okay.
Since I'm feeling I'm hiding stuff. There it is. Oh no, I'm hiding the repo. It doesn't work. Damn it.
Well, we can share the repo again in the URL. It's okay. But here, like, this is the only slide.
Continue.
No, it's fine. We can add it to the description afterwards, right? I think it's the only one.
Well, we'll type it in the chat. So just continue.
Perfect. So in this scenario here, this is what we did, right? So the challenges that they had was they would receive the information manually from the law enforcement, and then they would go forward and do the research online to capture all the information on the child. What we've done is we've built out a solution that allows Missing Children Society of Canada to automate the process in terms of understanding the communication patterns as well as the travel patterns online. What happens is the child registers for the service. If the child can't register for the service, then the parents would register for the service completely free. There's a portal that you would go to. And once they registered for the service, they would connect in their Facebook account, Instagram account, Twitter account, and then we've even left open like a future triggers. So if there's, you know, so right now we have TikTok is hot. And so if the API exists, so we can extract information from TikTok, then we can have that capability as well. Back then, there was no TikTok when the solution was built out, but we did provide the capability to have additional social media platforms plugged in or made available when, you know, other platforms became popular to add into the solution. So you have this webhook that would go in and would extract information on the child. So what would it extract? You know, you can actually get GPS coordinates if the child is using their mobile device, even if the GPS is turned off. It will tell us in terms of geographical region where the internet connection for that device took place. And so it would capture that information. It would capture who is the child in conversation with. And so, you know, give us a list of all the individuals that they're talking to. But better yet, we actually use cognitive services sentiment analysis based on the text that was inputted from the social media account to understand happy, sad, romantic intention, angry. What was the sentiment of the conversations with the individuals that we're speaking to? And this was all done via Azure Functions. Now, this was prior to all the other things that went on in terms of the Facebook getting in trouble, or Cambridge getting in trouble with regards to the extraction of data. Now, what we have, this solution is still running, but back then the APIs were wide open. They've obviously shut them down, because of what occurred back then. And so in this situation here, what we now have is, if you wanted to deploy this, if you wanted to do a similar solution, there is actually a process that you have to go through with each social media platform. Obviously, Facebook and Instagram would be at the same time, but you have the ability to still have this type of functionality in terms of capturing of information in respect to doing a sentiment analysis on the conversations that are taking place. It would require specific permission from the social media platforms, and you would have to provide them a business case as to why you're capturing this information. Luckily, when we built out this solution, it was in partnership with Missing Children Society of Canada and the Royal Canadian Mounted Police. And because we had that backing, obviously the social media platforms had no issue with us continuing forward with the solution. But like I said, this solution, what it did was it made the availability to understand the conversations that were happening between the child and those on social media. 90% of the abductions happen because of romantic intent. It's, hey, I like you. I like the way that, we're having this conversation. I'd like to meet up with you. Here's a place that we can meet. And that's the dangerous piece about this. And so it's understanding when that occurs, the probability of, this individual could be somebody that, this child shouldn't be talking to, and we'll have to investigate further. Now, what I actually wanted to do was I actually wanted to showcase how easy it is to implement a sentiment analysis, not only on social media, but on any documentation, or even a web call out to a specific page, or if you have a blog and you have comments that come out on the blog, you can actually go through and do sentiment analysis on the comments. I know sometimes some individuals get a bit heated and put negative comments on, and if there are comments that shouldn't be on your blog, you can actually automate the functionality of removing those comments using a combination of Azure Functions and sentiment analysis, or cognitive services sentiment analysis. And one of the questions I get a lot, and Frank, correct me if I'm wrong, or if this is a question that you get a lot, is, well, great, Anthony, I can do all this, but there's a cost involved, and I'm a student, or I'm a small business, and I don't have a developer on staff. How do I do this? How do I test this? How do I learn? I just want to learn the functionality. I'm not going to pay for learning the functionality. How does Microsoft offer that up in terms of learning? And
for all like any AI, like people are always worried that it will be complex, that will take forever to implement, and stuff like that. You're right on that.
It comes up a lot, right? We hear that a lot. It's something where Microsoft has struggled for a long time to make it easier. And that's why, I don't know if, obviously, Frank, you're familiar, but I don't know if the audience is familiar. Microsoft Learn, if you haven't tried it out, if you haven't checked it out yet, do so. And I'm actually going to show you a demo of why you need to check it out. Here we go here. So here is a lab on Microsoft Learn. This lab specifically calls Text Analytics, the API, from a testing console. This lab is completely free. This gives you the availability to go forward in the sandbox technology and test out the Text Analytics API for the functionality of analysis of a document called up in a browser to have an understanding of the sentiment that's occurring with this document. And I'm going to show you how easy it is to set up. This is done in what we call sandbox technology. So the lab that you see on the one side, provides you all the steps on how to reproduce this. But the actual solution itself, as you can see on the other side, it is all click-based. So once I've gone in and I've selected sentiment for my analysis, I'm literally going to select my region, which is East US. And all I have to do now is I have to add in my subscription key. The Microsoft Learn solution in Sandbox actually gives you the key for free. Obviously, it's on a free tier, so that's it's going to be very rudimentary analysis. But it's the availability to actually put forward the key specific to this for free. And then once you've entered in that key, and actually I just got to do something really quickly. Where's my key? Oop, nope.
Password 123.
Yes.
Exclamation
Isn't that always
point.
Isn't that always the key? I'm going to copy. Don't do that. Copy that. 1 second here. And we'll go back to my screen. And we'll go back to my desktop number 2, and there we go. So obviously it's not going to be that difficult, but I'll put in my key. There we go, and I'll send, and it'll test my connection in respect to, you know, is this what you want to pull? Here's the documents that you've loaded in terms of capturing that sentiment. Yep.
Let's go in the. Is it so? Right now we are both in the top right corner. Is it better? You think we'll be hiding less stuff?
Oh, it's fine. It's so this I just wanted to show really quickly in terms of the code that's made available in the HTTP request that you're putting forward. You're not really hiding anything both in the top right corner. It's okay.
I'm just trying to be in a place where, like,
yeah,
because we were both in the lower corner, and you are showing stuff inside the lower corner.
It's better to keep us in the higher corner, only because it'll show the response in the lower corner in terms of the test scores that are put forward.
Perfect.
So these documents are preloaded from the lab itself. Obviously, these are not documents that I've submitted. So obviously, it's gonna, if you're testing and learning out the functionality, it's something where it's sandboxed and it's a trial that you're going through. But this is completely free. You don't even need an Azure account to test this out. You can go for it, and you can actually copy the request in terms of to take it into your Visual Studio Code to start playing with and dabbling with and making changes to. Obviously, you would have to change the subscription key. So once you're more comfortable in terms of the labs that you've completed, you can go forward and create your own key. There is still actually a free tier that you can go and dabble with. But this is a great way to do hands-on experience in regards to this. And then just capturing the request body itself and implementing that into your own code and making changes. As you can see, it's doing the sentiment on the text that's made available. Yep.
Can we zoom? Or can we go like just one, like just the screen, the right screen? Can we go full screen that?
Does this work for you?
Nah.
The only problem is that because it's the
I
text
need to be side by side like that, or
I can make it full screen. There you go.
Yeah,
how's that?
That's good. And
I wanted to show
also,
the lab on
in
the
the
other
chat
side.
we had some people say, "Oh, I want to see more. I want to see more." So
yeah,
there you go. Thanks for the heads up.
So what's great about this is that, like I said, this is something where it's a point and click. It spits out the code for you. I could take this code, embed it into Visual Studio Code, and run the same test. It'll come up with the same response as you can see here. And then I can modify the code. So right now it's going based on the text. And if you can see, we have text in English. We have text in French for Frank. And we have text in Spanish for myself, right? So it's not just for Frank. For anybody else.
We just got rated. I don't know if you're familiar with that thing. So Coded Live just rate us with a party of 10. So we're 10 new viewers that just join us. Fun party.
What? This is my second time on Twitch. I've not seen the ratings before. So thank you. I'm very honored. It's awesome. But I wanted to show how easy this is in terms of testing this out, right? This is not something that's complicated. I'm very appreciative of the fact that we have these type of workbenches, is what I call them, in respect to building out of the code. I'm very much I'm not a proficient coder like Frank is. I'm more of let's copy and paste from certain areas and make it work. But this is such a great way for me to learn in terms of just the coding structure and how to call on the API. And it's hands-on. It's completely free. And the benefit of this too is that when I'm done and I close out this window, it'll actually wipe the sandbox. So none of my data, like if I go in and start manipulating data and I can use that API key, none of it is kept in memory. Everything is wiped at the end of this. Now, if you wanted to take this, code structure and save it on your Visual Studio Code or whatever coder you're using, it's fine, and you can use it later. But obviously, you would have to generate a new key for your API callout for the sentiment analysis.
There's different tier also, right? So like it doesn't need to be super expensive. There's very budget-friendly tiers.
So this is actually the free tier. So there is a free tier that's offered. When you're using the free tier, you're using a lot less threads in terms of compute power. So when you're doing your analysis, obviously we're doing 3 lines here. You can do it on the free tier pretty quickly. If you're doing a 2,000 page document, Yeah, right. So what would happen is a 2,000-page document might take you a couple hours to go through a sentiment analysis of the document.
Yeah, but then
right?
like it's free.
But it's free.
If you just want to
Right?
know, oh, like is it worth it, or time or whatever, use that. You know, put that something quickly. You try it, even if it takes
I
3 hours. Okay, that's cool. Now, like maybe I could think about spending more bucks on it and having it faster if it's worth it.
If it's worth it, right? It all depends on value. The biggest thing with this on social media is that you need instant responses to information, right?
Yeah.
So, especially when a child's life is in danger,
Well, like
you
in
want to
that
have
context, of course.
100%. No, 100%. But and I wanted to show just from a free perspective, it's pretty robust, right? You can do a lot. It's not that you can't do a lot. The benefit of doing it this way through Learn is that I don't have to set up an Azure account, right? If I'm new to Azure, I haven't dabbled with Azure yet, I want to test out this functionality, it's a perfect way to do it, right? And the URLs for all these labs are also made available in the subject text that Frank shared with everybody. So that's pretty cool. Let me get out of this guy and go back to desktop number 1. All right. So the one thing I want everybody to take into consideration, and this is something that we learned very quickly on the Missing Children project, was you can connect everything under the sun. You can capture information from social platforms, you can connect information from individuals, you can connect information from items. I know of one project where it's monitoring cows to understand when is the best time to milk the cow, right? Like it'll have a collar around their neck and measures their temperature, and when it's at a certain temperature, it's the best time to milk said cow. And the question though is why? Why do you want to do that? What are you trying to accomplish? And who does it impact when you capture this information? We forget about this a lot in terms of the essential relationship. It's not enough just to capture the information. This is what we learned like doing the Missing Children project. You must have the buy-in and collaboration with the business decision maker, those that sign the checks of the organization that you support or that you are working on behalf of. Operations. Is it secure in terms of the solution that you're putting forward? Is it something that meets the organization's needs from an architectural standpoint? And then obviously the developer as well in terms of coding out the information. No solution will be a valid solution or a working solution unless these three parties are working in collaboration on behalf of the organization they support to build out the solution. I've seen so many horror stories where, oh yeah, we're just going to implement this, and I'm not going to worry about security, or I'm not going to worry about the bottom line. It's important to the business. It doesn't matter how much it's going to cost. We're going to get this done. And it would just fall flat on its face. Or the business decision maker gets this bill that's thousands of dollars, and they freak out saying, what is this? I didn't approve this. Why are we going to build this? Very important that you have this relationship and an establishment. In regards to the Missing Children project, we were actually able to grab information within 7 minutes back then of all the information on the child, including sentiment analysis of the conversations that the child was having with certain individuals. What we didn't know, and at that time we hadn't included the Royal Canadian Mounted Police, is that there are laws in regards to the way that you capture information. Even though the information is being offered up as public on a social media platform, you still require permission from either the child or from the legal guardian in respect to capturing that information for sentiment analysis. And so that's why the portal was designed so that the child or the parent would log in and allow the solution to have access to the social media platform to gain access to those accounts. Now, it did lengthen the process from 7 minutes to about 24 hours. However, it's still quicker than the 30 days it would take originally. And this is where we established this, essential relationship diagram in respect to make sure that all parties are aware in terms of what you're trying to build out, and that everybody has bought in, or else, all the work that you've done for the solution that you build out is for naught. It doesn't impact anybody, or it doesn't impact the bottom line, or cost more money, or it was needless, right? You got to make sure that everybody is aware in the solution that you're building to make sure that going forward, this is something that's going to have impact on the organization that you support. So let's take it a step back, because I actually wanted to showcase, this is one of the first projects that I worked on. And this was something where, we did our analysis, we talked a bit to the business decision makers. This is something where, what is the problem that we can address with technology? What is something that we can, help automate? We did the Missing Children project, and that was a big one. And then, we started to look at IoT in terms of capturing of information, what have you. So This was a project that was built over a span of 48 hours. And what this was, it was the ability to use $2 mousetraps that we bought at Walmart and connected it to a Raspberry Pi. And all it is when the mousetrap is set off, it closes a circuit. And at that time, that is your trigger to capture the information surrounding the mousetrap. What we wanted to do was, in this scenario here, we had the ability to impact the marketplace that currently was not being proactive, but reactive. Restaurants have mousetraps all throughout the restaurants. Almost every restaurant has one, probably outside where the garbage is, or if you walked along the streets, you've seen those boxes that are rat catchers on the sides of the streets. And the challenge is, the pest control companies are not notified when they're full. They actually have to go around and schedule time to go by businesses to clean out these mousetraps. And so the initial thought was, what if we were to automate the response when a trap had been set off? To notify the pest control company to say, hey, trap has been set off, it's caught something, you need to go clean it out. And so we built this out in 48 hours in respect to understanding capturing mice. The trap has been triggered. There's a mouse inside.
You don't know yet if it was a smart mouse.
It could be empty. Yeah, it could be empty. It could be the mouse is taking the cheese without sitting off the trap. That is a possibility as well. But this is just something that we theorized in terms of its capability. But what was cool about this was we used this as the foundation. This was our starting point. This is where we started in terms of the project. What it evolved into was we started with 2 mousetraps, and we quickly realized, hey, we're getting a lot of information in terms of these traps being set off, in terms of how quickly the traps are being set off. And so that then turned into Power BI exercise in regards to, with the traps that are being deployed, where are the areas that are getting the most mice? Then we had the capability, then we had the thought, well, if we're capturing in terms of placement inside of a building and geographical where the traps are being set off, what if we were to capture other environmentals? So Frank, to your point, how do you know that you caught a mouse or not? Right? Added a camera to show the image of when the trap has gone off, what's in the trap.
Yeah.
Added the ability to, detect heat and cold. Are the mice more inclined to be in a warmer area? In regards to the light and dark, is it, bright or is it dark where the trap is? Is it catching more mice because it's where it's dark? We were able to build upon the solution. So the benefit here was having the conversation with those, that would be impacted in regards to the solution, getting their buy-in, building out that foundation of just a simple mousetrap that catches mice and notifies when the mouse has been caught. Then taking it upon ourselves to understand, in regards to inside of the building, where are all the mice being caught? Ingesting more information in regards to light, dark, temperature, and what have you, and then capturing all that information and using machine learning to have a better understanding as to, this is where you should put the traps in this building because of all the information that we were capturing.
Oh, wow.
But as you can see, cool. Right, so we're layering on the solution as we go. This wasn't hey, we're going to go and catch mice and we're going to throw out AI and we're going to rub AI on the solution and we're going to catch all the mice. This was a slow build in respect to, and this is something that Microsoft services, for the facility services are actually looking at in terms of their implementation for this solution. Obviously in a bigger scale, they're not using the $2 wooden mousetraps, they're using the bigger boxes. But the availability of building upon this platform, and it's the reason why we open this up as open source, and I'll show you how other industries have actually taken advantage of the solution. It's the ability to build upon the foundation of just simply notification, a trigger that a mouse has been caught. With that trigger, can you take a picture at that trigger point? Can you, capture light or dark? Can you capture temperature? Yes. Feed all that information to machine learning in terms of the environmentals and the light and dark and how many times the traps are being set off in a specific area. And then machine learning will actually go through and say, these are the pinpoints and the hotspots where you should be putting the traps to catch the most mice. Because of the fact that you're saying that, in darker areas that are a certain temperature is where you'll catch the most mice. And that's one of the environmentals that I'm capturing from this building. Put the traps here and you'll catch the most mice for you.
And mouse are smart. There's a YouTuber I watch, Matthew something. He's a woodworker. But from time to time, like he had some mouse issues in his workshop. And he set a camera and he just decided to play with the mouse. So he put some labyrinths with he was putting food and getting the entry smaller and smaller and smaller to check how they can continue to pass. he did something where they need to jump and how far they can jump, and they get better. It's incredible. I will share the link after if you want.
Yes.
And
Please.
another guy that is also awesome. He worked at NASA before, and that's on YouTube also. And it's a different guy. It was with squirrels. He did the full ninja warrior parkour. Super. So like those animals, they learn also. They adapt on a bunch of different stuff. So you need to adjust all the time. Also, your reading, right?
If you watch the squirrel one, what I found fascinating was the squirrels were always looking for ways to circumvent the amount of running going through that whole thing, right? They were trying to climb the poles underneath. They were jumping from higher areas and trying to jump on specific, aspects of the jungle gym that they had to run through. They're very intelligent animals. And so having that capability of understanding, well, this is what they're doing in terms of the patterns, and then even the patterns changing. So something as simple as the lights in a specific room were turned on 15 minutes earlier than usual would affect the pattern of where the mice would travel within the building. And this is something that, machine learning would have to understand in terms of when do the lights go on in this room and come back down? When does the temperature change? Summer, winter, fall, the whole thing, right? It's not just a stagnant, this is how it happens every day, right? Even minutes make differences in terms of temperature and light and dark in terms of the patterns of mice. So, they are intelligent, and to do that in such a way where, you're taking into consideration their intelligence, you're taking in consideration living patterns of individuals, understanding the habits that occur. We were catching mice like really rapidly, and people were taking notice in terms of the solution. And that's why, so we've offered this all up as open source, as well as the Hackster.io build out diagram of the IoT device itself, which in essence is just a simple push button sample. So we've replaced the push button with the mousetrap. And as you saw, it's pretty rudimentary. It's, had aluminum foil, and obviously the one that Microsoft Services facility services is using is a lot more advanced. But this was something that we built out in 48 hours and was able to prove out this solution. And it was their first real foray, not in just the IoT, but also machine learning, right? And it's that whole understanding, this is all the data that we're receiving. Can we capture more data? What can we do with this data? How does it benefit in respect to what we're trying to accomplish with the data? Does it have an impact? If I was to say I wanted to know of every mouse that I caught, is it a brown mouse or a black mouse? Does it really make a difference? Or do you just want to know that there's a mouse in the trap, right? Like these are the questions that you would have to go through, in respect to what's the data being used for? What are you doing with the data? How is it going to impact the solution? How is it going to impact the organization that you're supporting in terms of this implementation? Now, as I said, other organizations have taken advantage of the solution, and it's the same mousetrap solution. Frank, do you still have these out by you in Quebec?
Maybe downtown, not around, but maybe downtown in Montreal.
You are starting to see them less and less frequently, right? I know a lot of people are reading their news online, so I still enjoy the newspaper on the weekends. So it's I haven't bought one from a box in a while. But what's interesting was, back in the early, let's say 90s, early 2000s, these were everywhere, right? They were on every street corner, outside of a convenience store. They're readily available. But the challenge is to maintain these boxes. It's a lot of work. It costs a lot of money. And so when they saw the mousetrap solution, they said, hey, can we adopt this to other solutions? They said, of course. So instead of using a mousetrap, the trigger that they have here is a scale. So a mechanism that's inside of the newspaper box that weighs how many newspapers are in the box. And so the trigger here is when there is down to what they usually weigh around 2 or 3 papers, they know that the box is almost empty. They're not checking for light and dark, or they're not checking for temperature. What they are tracking for is how many newspapers are left in the box, how frequently or how fast is this box selling out, notifying the person who fills this box, hey, this box is almost depleted, you need to put more newspapers in, but also providing the information of where's the best places to put these newspaper boxes to sell the most newspapers, based on the architecture from the mousetrap. Better yet, there's a police department, unfortunately I can't say where, but there's actually numerous police departments around the world that have taken the mousetrap solution and have changed the trigger to be the sirens on top of the police car. In this scenario here, what they're actually able to do is track where are the most calls for police occurring in the geographical area so that they can provide the most support. This scenario here, it made it in terms of, individuals, police would cruise through certain areas because they were told to do so. Now in this scenario here, they can actually be mindful in terms of, well, we're getting the most requests for support in these areas. And then machine learning saying, well, in terms of your travel patterns, this is where you should go, cruise certain areas that are getting the most requests, as opposed to just driving your normal traffic pattern area. So that police can be more proactive in helping citizens as opposed to just waiting to go, on a specific tour. They can actually go to specific areas that have the most requests. And what's cool, like I said, this is all built off the mousetrap solution, which in essence was built to catch mice, but using the same technology and even the same machine learning algorithms. It's helped both, the newspaper industry and the law enforcement in terms of being more proactive in enabling its citizens. So the next project we sat down with Toyota Canada, and they had an interest in terms of understanding the not the reliability of the cars. There's situations where parts will fail in a car, and it's because of different geographical regions. I know out east where we are in Ontario and Quebec, Frank, correct me if I'm wrong, we use a lot of road salt in the wintertime, right? We get a couple feet of snow.
But now there's cities that doesn't have that, so they use a mix of rocks and something else, salt,
Yep.
Sand.
Actually, in Seattle, and so Washington State, they use fish bile. So they don't even use salt at all. West Coast cities, for the most part, you are using organic means in terms of dealing with the snow. But they have other issues in terms of the salt water because they're so the proximity to the ocean. And in some scenarios like BC, you have the issues of, you have the mountains, right? So that puts another strain on those cars. And Toyota had this scenario where they wanted to understand, how can we be more proactive in understanding part failure in vehicles from around the world, in this instance here, from across Canada. And the exercise here prior to was, in Frank, this was crazy. They were capturing a month's worth of data manually in Excel spreadsheets out of 300 mechanic shops across Canada, so 300 dealers across Canada. They were capturing the information in terms of the parts that were failing manually in Excel. And then they were shipping the documents to Toyota Canada, based here in Ontario. And then they were using Microsoft Access. Do you remember Microsoft Access, Frank?
Oh, yeah, I remember.
Right,
No,
so they were
no,
using...
No, we'll have trouble sleeping tonight because of you.
So they were using an ODBC connector to connect to the Excel spreadsheets, to extract the information and ingest it into Access, applying their algorithm that they created in-house, which was phenomenal, by the way. This is, something where it took years to get to the point that they were at. And it would take them up to 24 days to do an analysis on one vehicle in terms of part failure using Access. The amount of data they would have to choose.
Access was, and it's still good. Like, I'm making
still very good,
but it is. But when you're using for the correct purposes, like, it's not the answer for every solution. If it's one user or two user limits, small piece of data, it's cool. It's working. Like, it's easy. You could build stuff very quickly. But after that, use the proper tool.
Like I said, 300 dealerships across Canada, ingesting information from Excel that was being emailed back to the central office that were then digested, 24 days worth of data. Just insane. So they're like, can you help us?
Can you stop, please?
So here's the thing, right? So we actually had to get in somebody who can do the algorithm to code it out for us, because we couldn't use the ones that were available in machine learning out of the gate in terms of the workbench, right? So there was actual coding that was made available for the algorithm to be ingested. In essence, we call it the black box, that all the information that was being siphoned in, still, by the way, through Excel, was being siphoned in through the black box into machine learning workbench. So, the data would be called in through Excel, into machine learning workbench, and then it would be ingested into the black box. The black box would digest the information, it would go through. It still took 48 hours. That's how much data, and that's on one vehicle. So they went from 24 days to 48 hours using this solution. Now, we did this on not the free tier. I think it was two levels above the free tier. And that's the thing, right? It comes down to your cost based balanced against how fast you need that information. Yeah. And Toyota Canada, they felt that 48 hours was more than enough time in terms of digestion. But what was cool was that we had the ability to then understand, okay, in this specific vehicle for Toyota, we can see this part failing in this region because of X, Y, and Z, and this other part failing because of X, Y, and Z. So having the ability to be proactive and do the recalls in specific areas, because why do a blanket recall across Canada if out west is not being affected because of the environmentals that are out east, right? You don't need to. So you just call out the one area and say, hey, we're going to recall this one part because we know it's going to affect your vehicle because of the environmentals that you have here. So they can be more proactive, right? Sorry.
Yeah, I wish they had done that before. I had a lot of trouble this winter with my car.
Oh, really? Okay. Yeah, but it's something that's ongoing. This is a current.
But at the end, I brought the proof. I record everything, because I find out the pattern by myself. They were like, yeah, we don't know, just call us. I was like, hey, the car just doesn't. It can start, and then at one point, it just doesn't start, and then you wait 20 minutes, an hour, and then it will start again.
That's weird.
But so I prove how to repeat it, and they find the trouble. And
what was the trouble?
Fix it. But but it took me the full winter.
Do you know what the trouble was? Was it is your
electronic? Yeah, the problem was the car is an hybrid, but
okay.
Yeah.
Oh, you'd be surprised. The information that you could pull from the ODB2 in the vehicles these days. I know back when I was a mechanic, there were no computers in the cars. It was something where you'd have to know in terms of sounds or what the car was actually doing to figure it out. My 1990 Volkswagen Golf, which is the first car I had, that had the first OBD2, and I remember connecting it via the serial port to my then 486 computer with this long ass cable to understand just from the Golf what it's doing. And now I have this handheld unit, a Cobb tuning unit that connects into my current car, and I can tune, okay, this is the gas ratio I want, the gas to air ratio to turn down the amount of gas that it burns, right? It's amazing in terms of the information you can capture today.
Yeah, I didn't think about that. For me, it was just repeating action and recording the temperature and different things. And then I brought back the solution. But yeah, automating the process would have been better. Just
Well, that's the thing, right? We don't know, you don't know what you don't know, right? So the ability to now, go for it. And so obviously we can't share the proprietary information from Toyota, but they were nice enough to work with us to build out a lab. And so the URL's there on this. And I'm sorry, Frank, there's another URL I'm going to have to add to the docket. But this one here, what this does is it does an analysis. Let's say you want to go out and build your own car. And so you select which parts that you want to build your car out with, certain grade of chair, like the seat that you put in the car. Is it going to be leather? Is it going to be cloth? Is it going to be vinyl? The type of radio that you put in the car, how many doors, 4-door, 2-door, what have you, size of tire, you name it. Put all the information in. And then it will do an analysis based on current market trends on how much you should charge for that car. What would be the MSRP that would allow you to be successful in selling that car to the general public? And so it's a very interesting exercise to go through, and all the steps are listed in the post that you see here to replicate. I'm building my own car. This is the type of car I'm building. I'm going to build a sports car. I'm a big Mopar fan, so I love the old 70s Mopars. If I was to recreate one of those, what would be the cost in recreating one based on the steel that I use, based on the tires I use, the engine size, you name it. You can change pretty much everything, and it will provide you with the best MSRP that you should be charging to your customers to make your car successful. So it's a very interesting endeavor. And again, to do this lab is completely free, and it allows you to go and understand, just in terms of utilizing the machine learning workbench in terms of adoption of, how do I ingest this data? And what's great about it too, in terms of the way that we built out the solution, all the data and all the pricing is already made available for you. You're just literally connecting in that data source from the machine learning workshop to go forward and then just understand how you can have the output in terms of what is the best price to sell your car at.
I'm having fun. I have some people saying like hello and bonjour. They don't know that you are also Canadian, so.
I am. Parler un peu français. All right, let's continue on.
Yeah.
So we talked about this, right? So a lot of information is out there. There are 32 billion devices connected in 2020. They're all capturing information. What does that mean? Do we just take all the raw data and push it out to the cloud? Mm-hmm. You're starting to see this advancement or the evolution of the devices that are capturing information being a little bit more intelligent. And this is what we call the intelligent edge. It's the ability to have understanding at the entry point of where the data is being captured to understand, what does this data actually mean? Do I need to, push all the raw data up to the cloud, or can I create a outcome here on at the edge and the ability to understand the data that's coming in to impact the data and reduce the amount of data that I'm putting out to the cloud? Because any data that you transport costs money. Any data that you store costs money. Any data that you process costs money. So if you can have a more precise data capture at the entry point, then you don't have to worry about, the additional cost of sending raw data up to the cloud. It can all just be captured at the entry point, digested, rudimentarily digested, and then pushed out to the cloud. And that's where a lot of solutions are moving today in terms of really making the devices that are capturing the information intelligent. This is what we're calling edge computing. So the ability to take the information, understand the information that's being captured at the entry point, and then pushing out the result. So having a rudimentary algorithm that's taking place at the entry point to have a result and then push the result out to the cloud as opposed to the raw data. So this is, the catalyst for this was this solution here. And it wasn't from a perspective of computing cycles or the amount of data that you're pushing out. It was specifically because of connectivity that we were required to have this type of functionality. This is the Henry Larson. This is one of the biggest ships that is available on the Canadian Coast Guard. It costs millions upon millions of dollars every time the ship leaves. That's gas, that's the people that staff the ship, that's all the emergency services that are available on the ship. And don't get me wrong, people's lives, priceless. There is no cost that, in terms of saving people. But what happens when, the ship leaves the shore and you want to be proactive in terms of the services that are going forward to rescue the ship? In some scenarios, it's not individuals in distress, it's the ship, the boat that they're on has been disabled. And in it being disabled, they're calling in a mayday, we're in distress, we can't move anywhere. Obviously there's, a walkthrough of scenario in terms of what's going on. But, to have a real idea, you want to visualize, you want to see what's actually occurring. So we partnered with a startup based out of BC, Indro Robotics. And it was them who were taking drones and flying them manually. These are gas-powered drones. These are not the drones that you would buy at the Best Buy or at the Walmarts that you would dabble with. These are actual, full-on professional drones that they would build. And they would actually be able to fly them up to 6 hours. So 3 hours out and 3 hours back, go out to a scenario, take film of the situation of the ship that's in distress. And then, once the information has been captured, they would actually have to fly it back to their central office. Once they've flown the drone back to the central office, the imagery, the video would have to be analyzed manually. They'd actually have to go through all the film that the drone had captured to understand the situation. So at its most extreme point, it's 3 hours out at sea and then 3 hours back. And so that's 6 hours. And then analyzing on the tape, obviously they're not going to watch it at regular speed, but it's still going to take a couple hours to digest all the information. What happens when there are individuals out in sea and the distress signal has gone off of the boat, but there's, people are radioing in, but the boat is either the communications are down or there are people that are, in the water and unable to speak to the operator in terms of the distress. What do you do in those scenarios, right? And that's why the drone solution was put out there, because prior to, a boat would have to go out and maybe, it's just the communication system was down. Nobody was actually in distress or in the water. And the boat, all that was required was a tugboat. You didn't need to send out the Henry Larson. So we partnered with Indro to make the drone self-aware. But our biggest challenge was connectivity. So because of the fact that they were going 3 hours out at sea, there was no cellular communication. There was no towers that would be able to, extend their coverage out to these drones. So we looked at satellite coverage. And the challenge with satellite coverage, if you've ever used satellite services before, they're very expensive. And so it didn't make economic sense to use satellite coverage for these drones. So we then thought, well, how do we make the drone understand what it's looking at? And when it understands that there is a situation which is life or death, then go, fly back into coverage to say, hey, I just detected this. You need to send somebody out immediately, right? Because again, when you're saving individuals, it's about the effort. It's, time is of the essence. You want to make sure that you get emergency services out as fast as possible. So in this solution here, what we actually did was we went forth and we made the drone self-aware. And actually, I'll reverse back for a second. We made the drone self-aware to understand what a life jacket looked like in the water. That was the trigger. So in the understanding of the life jacket was in the water, trigger number one. Trigger number two, because as a fail-safe, we had to actually understand that there was a body mass that was inside of that life jacket. Life jacket in the water, it's fine. It's okay. I'm now paying attention, but it's also the life jacket has blown off board and there's nobody inside of the life jacket in the water. And so it would capture optically to say, oh, I discovered a life jacket. And then the second step will do an IR scan to make sure that there is a body mass inside of that life jacket. And then it'll do a capture of how many life jackets can I actually capture that are in the water. So 1, 2, 5, whatever that may be. Understanding that information, that triggers it to also capture environmentals. So understanding, is it windy? Is it cold? Is it hot? What is the temperatures? To do a best guess of what the temperature would be of the water. This is all being done on the drone without connectivity. This is all the intelligence that was programmed on the drone in terms of understanding what it's looking at in terms of the scenario, capturing the environmentals, understanding, okay, in terms of what I've captured in terms of environmentals and all the data that I've now digested, this is the probability of hypothermia sitting in those individuals that are in the water. And then have an understanding of this is how much time I need to go out and get rescue crews out here to help out the situation. When it captured the information, it would then fly back immediately back into the central office or into coverage, not even to the central office, to notify, hey, I've detected that there's 4 individuals in the water. These are the environmentals. You need to get out there because in 45 minutes, these individuals are going to contract hypothermia. And it was so cool that, before the tape was even reviewed, the drone had already provided the instruction back to the central office to say, this is the situation. Provide, obviously, a capture, a camera shot or photo of the scenario, but also provide the information alongside it, which was a lot less as opposed to streaming the video across to the central office, which was the initial project. That's what they wanted us to do, and it was too costly to do that, and that's why embedding the intelligence to the drone to make it understand what it's looking at was much more beneficial, especially from a cost perspective and then from a reactive perspective, because tape didn't have to be analyzed. It was just the one shot with all the environmentals and the calculation for hypothermia.
Awesome.
So what I'm going to actually show you is I'm going to actually show you a demo similar to what we did with the Canadian Coast Guard, but in essence in the same lines. I've actually gone forward and captured all the information on the demo because of the fact it does take time for analysis and we only have so much time on the show. But I wanted to make sure I can show to you, the audience that are watching, what we've done in terms of the solution. And I'm actually going to port the solution out to something else. And this is why I share all the GitHub repos and all the URLs, because you can build such amazing things on top of the solutions that we're sharing. And I'll show you how easy it is to build it once we're done here. So here we have the Custom Vision AI workbench. This is where I can go in and ingest all the information and teach cognitive services, specifically Azure services, what certain items are, what they actually look like. So what I'm going to do is I'm going to go in and add images, and I'm going to do this on behalf of a hardware retailer. Insert hardware retailer here. And Frank, what do you see on the screen? What tool is that, Frank?
I was about to say anything except the good answer. A hammer.
Nice. So these are hammers, right? Frank, how do you know that's a hammer?
Because my father teach me what a hammer should look like. I see a handle, I see a part that I can smash something. I see the curvy part sometime. I don't know how you call that the tail. How do you call the other?
I usually call it the pry. So some hammers have a pry, and some hammers have a knob, and the knob is to make a specific hole in something or to bend metal. But in the pry is for take nails out, or if you want to pry something off. Different types of hammers. The similarity is they have this blunt object on the end and a long handle to grab. In terms of you're going to whack something with it, right? And like you said, you were taught when you were a child by your father, that's what a hammer is, right? This is how we teach custom vision to understand objects. We get as many pictures as we can of a hammer, and we tag these images as a hammer. And so now, we're going to take another object, and this is what's the second object, Frank?
A wrench? Is it a wrench,
in
English?
It is a wrench. You got it. I'm testing your English. Look at that. So here we have a wrench, right?
Can you say clé à molette?
Say what? Clé à molette?
Yep.
Oh, there you go. So I there you go. I just learned French there.
Yeah. So key is that's the key. Clé is the key, and amolette is the moving part.
Oh, that's cool. So that's how you would say wrench.
So a lot of people will say wrench because clé à molette is definitely very long.
Now, is that Quebecois French or is that?
No. Clé à molette is the proper French.
Is proper French.
I guess it's French. It's not slang.
Oh, I'm not saying Quebecois is French. Don't get me wrong.
There's slang everywhere, right?
Yes, of course. In every language, right?
Yep.
So here we have the hammer and the wrench, and we've tagged the images as such so that you can detect what a hammer is and what a wrench is. And this is how we teach cognitive services. The cognitive services will go through, custom vision AI will go through and understand, okay, the hammer has the blunt object at the end and the long handle. The wrench also has a long handle, but it has, this apparatus that's at the end that, in essence, what grabs on the bolts. So that's the differentiator between the hammer and the wrench, right?
Yeah.
So we take this information that we've tagged, and now we're going to train the custom vision API to understand the differences between the two.
So Anthony, can you give us a little bit of context about this tool? Because maybe some people just join, they are wondering if they need a key or something to use that service that you're showing up.
So all you have to do is you have to go to customvision.ai. There is a key that you generate, but there's a free key. So similar to what we had in terms of the sentiment analysis with text analytics, all cognitive services have a demo tier that allow you. And so in this free key, I'm able to distinguish between two objects, right? Obviously, if you wanted to do a lot more, you would have to go into the paid territory. But if you're just trying to do something for free and testing out the functionality of the service, all you do is you go to customvision.ai, you sign in with a Microsoft account. It doesn't have to be at outlook.com or at live.com. Or Frank, do you still have an at hotmail.com?
No, I switch it to Outlook.
I still have a Hotmail. So I have a Hotmail from when I was a teenager. But I do have a Hotmail account as well. It doesn't even have to. You can use your Gmail. You can use your ISP's email account, whatever that you've created. Create yourself a Microsoft account. You can log in for free. You can use the free tier to test out the functionality. When you want to bump up, you can as required. Again, obviously based on the amount of objects that you want to analyze, as well as how long you want the analytics to take. In the free tier here, to distinguish between the two, it took about 15 minutes to go through. And I didn't want us to sit here for 15 minutes to watch the analytics occur, and that's why I took the screenshots. So in terms of the training of the two objects that we've captured, this is the outcome in terms of the precision of detection of a hammer and wrench. As you can see, in terms of precision, both understanding what a hammer and a wrench is in terms of custom vision service. The recall is a little bit less on the hammer because the fact that the hammer had a lot more differentiators. Some had the knob at the end, some had the pry at the end, some of them were mallets. So technically it's not really a hammer, it's a mallet, but it was thrown in there as a hammer, just to show if it's a blunt object on the end with the long handle, and that's the hammer. And you'll never get 100%. This is actually pretty good scores. Usually the scoring average on the recall is around the 70% mark, which is still good. And it only gets better in terms of the more data that you feed it, of course. but sometimes you don't need to feed it that much in order to get that score. We are only analyzing 2 objects, so it doesn't really have that impact. But what I wanted to do, and remember, we wanted to showcase this capability in terms of edge computing. So we don't want the device that's gonna do the analytics between the wrench and a hammer to be connected all the time. We want it to have the ability at the endpoint to make the distinction between a hammer and a wrench. And so what we're actually going to do is we're going to export this logic. Now, in the case of the drone, what we actually did was we exported it as a Docker file. And so this Docker file would run on top of a Raspberry Pi equivalent, was built proprietary for the drone itself, to run the analytics of what it's looking at through the optical camera, as well as the analytics that was run through the IR camera. In this scenario here, what I'm actually going to do is I'm going to keep it open source, going to keep the theme as open source, and I'm going to export it as an Onyx file. So this is going to be exported in terms of the detection between a hammer and a wrench as an open source Onyx file that can be imported into a plethora of solutions. And I'm going to show you an example here in terms of what I've inputted it as. And I'm actually going to make it a little bit more robust. Obviously, I'm showing you quickly in terms of distinguishing of a hammer and wrench. The solution I'm actually going to show in terms of the endpoint using the same workbench, I was actually able to distinguish between 75 objects, and not using a drone, but using something just as cool. So what I'm going to do is I'm going to export my Onyx file. So I'm going to export as 1.2. And Frank, you're probably going to guess. You could probably guess what I'm going to in regards to this now, right? So I've opened up Unity, and I've taken that Onyx file and I've created it as a model. So what happens now is the device that I'm using will pass through all its imagery through this model to do a detection of one of 75 objects that I'm looking at from this device. And the device in question is a HoloLens. And this is a real-world solution that's been taken up. It's in Eastern Canada that they're using this solution, that they're actually going forward and using this for search and rescue. And what they're doing is, because the devices don't have connectivity out in certain rural areas, the ability to have the device have the intelligence to understand what objects they're looking at makes it a lot easier for rescuers in terms of capturing of information when looking for individuals in deeply wooded areas and what have you. In this scenario here, what we're doing is we're taking the model that we've just trained on 75 objects, placing it on a HoloLens without connectivity, based on the path of the camera. So the code passes through the optics that are coming in the cameras on the HoloLens itself through the model to have an understanding of what they're looking at. There's the URL for my GitHub repo that includes this project that you can go forth and play with this technology. And don't worry if you don't have a HoloLens. I actually have a HoloLens 1, not even a 2. But this solution will work on 1 and 2 and other objects or other devices as well, which I'll showcase in a moment. But I wanted to show you the results. So using this device, no connectivity, looking at objects, walking around my house. And so here's a video of me actually looking at, my HoloLens is detecting that this is a basketball. And as you can see, it doesn't show it at 100%.
I don't see the video now.
You don't see the video? I'm showing a video. So
okay, now I see grass. Okay, it's moving. Now soccer ball.
So it should be looking at a piano right now.
Now shoes. A piano.
This is good to know. Okay. And so now it's looking at my old laptop, right? So the ability to go around.
Well, we got a little bit delay.
Yeah, that's fine. So the ability to go around the room and detect objects without connectivity from my HoloLens, that 75 objects without connectivity, cool. Right? It's pretty amazing in respect to what you can accomplish. And again, this is done through Workbench. I had definitely friends help me with the Unity code to put the model in between the optical recognition into the before the CPU. But the ability to do that on a HoloLens that wasn't built to do that type of functionality was crazy. If you can't get your hands on HoloLens, there are a plethora of cameras that are available to you that you can go forward and grab. This actually is the Azure SDK kit for Kinect. If you remember the old Xbox 360 and even the Xbox One, my Xbox One came with a Kinect unit. You had the ability to play games optically, and your body would be the controller in essence that you would use to play the game. This tool here is based off that research, so it has the same optics capability as well as IR capability that you can actually go forward and see objects optically, see objects via light, and see objects via IR to have an understanding of what you're looking at. You can take the code that I've shared with you in my GitHub repo for the plugging in of machine learning, the Onyx export, custom vision AI workbench, exporting the Onyx file as a model file into Unity, into C#, into Node.js, whatever technology you want to utilize, using this camera plugged into it would have to be plugged into a computing source. Could be a Raspberry Pi, could be anything, an actual computer or laptop, you name it, and then have the ability to recognize objects or recognize thermal scans, whatever that you may be in terms of what you've coded out as a model inside of the custom vision AI workbench, which is pretty cool. And that's why I shared the URLs for the...
It's higher than cool.
Well, this is why I share the GitHub repos that I do, because I build them in such a way where it's something where you can add to, you can build upon. I've had a lot of people push to my repo in terms of, hey, this is a better way to do this. And I love the open source community for that, because of the fact that they're passionate about helping others be better. I'm, not the best coder in the world. I'm a hobbyist in terms of coding. Architecture and infrastructure is more my background, but the enablement that's come through utilization of workbenches has been so eye-opening for me, and then just with help from individuals in terms of embedding code for these models, and the outcomes that you can create are phenomenal in respect to the solutions that are made available. So in terms of what we did with the drones, again, because we open up the code source as open source, here's a organization in Australia that has taken advantage of the same solution. And instead of using it for optics, they're using the IR specifically to understand the saturation levels inside of farmers' fields to know, how much water is in the soil specifically. And using this solution based on the drone scenario that we built out with Indro, they're able to understand, okay, well, this field needs water. And it's attached to the irrigation system in an automated way to, actually turn on irrigation when the soil is past a certain level of saturation, meaning that there's no water in the soil or very little water in the soil, and to optimize the yield of crops that are there. So corn needs more or less water than tomatoes, and so on and so forth. This solution actually automates the whole irrigation process to best suit the vegetation that's trying to be grown, based on the solution that we've offered up as open source with the repo on the drone solution that we built out. This solution here uses a proprietary IR camera, but you could, if you had a drone that was big enough, use the Azure Connect SDK solution to plug into a computing source to have a deduction of, is there enough water inside of the soil that's there itself, which is pretty cool.
Indeed.
So this is a question I get a lot, and Frank, you can see this animation that's going on right now, right? Have you seen this? Have you seen this before?
Nope.
So this was when the HoloLens first came out. It was like, oh my God, this is amazing! I'm gonna see mixed reality, and I'm gonna watch the Super Bowl on my coffee table. I don't have to watch it on TV anymore. I can see it in real time, live on my table with all these holograms, right? This is when the HoloLens first came out and didn't know what we're gonna do with it, and there was all these ideas. But remember what I said about in terms of the essential relationship. You have to have buy-in from the business decision maker, the developers, and the IT pros in terms of the implementation of your solution. Obviously, there is no such thing as a bad idea. Creativity, is what you think of it. And, there's sometimes that there are problems that we haven't even addressed yet because we don't even know the problem exists. So in scenarios like this, in terms of what is the future of computing, this was cool, but this didn't address a need. It was something that it would be nice to have. So, the evolution of the HoloLens was such that, had the ability to virtualize, instead of using cadavers, you can virtualize the human body for medical students to learn how to become a doctor. For mechanics, I know the Japanese Airlines is using the HoloLens to understand the parts inside of airplanes in terms of the mechanics on how to build and work on that. But again, that's still optical. That's still not using computing services. That's just using visual tools. What if we were able to take what we're doing with the HoloLens and the fact that HoloLens can recognize objects and use it as an input for computing? So this was a project that we built out with a partner called T4G here in Toronto, where we actually had the ability to understand the pipes that are running through the walls and the pressure points of those pipes. So the amount of water that was running through the pipes. I don't know, Frank, if you've ever experienced a water break at your house or at a company. I remember one time I had a company that I worked for, millions of dollars of damage because a pipe burst inside of the company. It was too cold outside. and the pipe burst and caused damage to a lot of equipment. Sorry, Frank, you were going to say something?
I was just saying it happened twice.
Oh, okay. So you have experienced this though.
Oh yeah. At one point, they called me in the middle of the night because my well, it was like pipes failure. It was my hot tank that broke in my store,
okay.
but the store was inside the subway station, so the water was dripping on the rail. So they called me at 2 a.m. to say, "Hey, come and go in your store."
Wow.
So they opened the station just for me, so I could go. It was very, very fun.
So this is a solution that we built alongside T4G. Now, the analytics occurring in terms of the pressures of each pipe, that was not done by the HoloLens. That was done by Azure in terms of machine learning to understand the flow of, there was regulators that was available inside of all the pipes, understanding the water flow. Sorry, Frank, you were saying something?
Just, it's cool.
Oh, okay, sorry.
I should mute myself.
No, it's fine. So you're understanding the water flow that's happening in the pipes, right? And you're understanding where the pressure points are in the pipes themselves, and it does the reporting out there. Now, you would say, okay, so why wouldn't you just automate this, right? Put actuators on the valves to reduce or increase the amount of water flow that's going through to alleviate the pressures. Part of the regulations, and this is why the business decision maker is also involved in terms of the solution, is that there has to be a human component in regards to the piping systems. It can't just all be automated. There has to be checks and balances in regards to actual humans going forward and regulating the water flows that are occurring. Sometimes there was a hatch that would allow for that access to the valve, and sometimes there wasn't. Sorry, Frank, you're saying something?
No.
Nope, sorry, I thought you were saying something. Okay. So prior to, if there was a problem and the valve was behind, there was no hatch that was accessible to that valve, you would have to, in essence, break the drywall. And it's happened before, and that would cause damage, and there would be cost to repair it and what have you. And sometimes they would just, put a hatch in its place. With the HoloLens, we were able to, the information would provide it to the HoloLens to have an understanding in terms of the pressure points that were inside of the pipes, that were inside of the walls. The HoloLens would provide you a graphical representation of the pipe layout behind the walls. So you actually could visualize these are the pipes that are behind the drywall without tearing out the drywall. So a plumber can go in, put this HoloLens on, and have a full schematic in real time of what's behind the drywall to understand where all the pipes lie and all the bends are and what have you. And then, because there has to be human interaction in regards to the pipes themselves, the plumber or individual wearing the HoloLens, all they would have to do is look at the specific valve. And so if you've ever used a HoloLens before, there's a focus point that's available that you would, in essence, it's like a mouse, you would look at a specific object and interact with it. So in this essence here, I would actually look at the valve itself, and then using my motion, I would turn it on or I'd turn it off, right? Using my hand motion in front of the HoloLens. Looking at the valve, and then making the hand motion to turn on or off the valve itself. Because of the fact that regulations require human interaction, that ability to use the HoloLens as a portable input device for computing, not the computing device, because that was still done through Azure, through machine learning, in terms of this pipe is going to have issues, you got to go alleviate this pressure. It was the ability to use this device as an input device in conjunction with the machine learning aspect to address that human requirement of interacting with the pipes themselves. This solution here, I wanted to showcase it in terms of where computing is going, and the fact that traditional computing doesn't mean that you have to have something in your hands anymore. You could be wearing it, or it could be something that's, in future just seen, not even requiring an apparatus, right? That's coming. But I wanted to show in terms of these are real world scenarios, real world solutions that we're looking at in terms of testing out the functionality and capability of the technology to advance us to do more, to achieve more, to be more capable. So this is something, that then comes up, right? Anthony, it's great. You capture all this data, there's optical data, there's relationship data, there's, data that's based in Excel spreadsheets that are being ingested into Access. Awesome. What about the ethics aspect of it? In terms of the individuals that are in the water in the Coast Guard, are you capturing faces? What happens to that information to capture faces? This is a hot topic, right? Even with the Missing Children Project, we have a multitude of countries that are implementing the solution. So the Missing Children Project is deployed across Canada and across the UK now. Brazil and other countries are looking at this technology as well. But a lot of requests came in terms of facial recognition, and that's it's a very touchy subject in regards to Is it ethical to recognize faces? Is it ethical? There's a lot of things that you have to take in consideration in terms of the data that you capture, right? Usually when it's a facial recognition request, we at Microsoft take a step back and say, unfortunately, we can't participate just from an ethics perspective. It's something that the organization wants to move forward on. It's totally in their right to do so if they feel it's fit. We at Microsoft do not, just because we don't want to move forward in terms of that, because for us it's an ethical issue. But there was an opportunity that had come to us from an organization called HomeAccept, which is based out of Nova Scotia, that wanted to have a scenario to enable senior citizens to be in their home longer. The biggest challenge, they want to be independent. I don't want to be living at home, so I want to live in my house as long as possible. And to do so, usually their loved ones, their families, they'll give them one of those buzzers or the beepers that if they're in distress, they press the beeper and help immediately comes out to that individual. If your parents are stubborn, like my dad is stubborn, he'll never wear one. He'll never remember to put it on. And so HomeAccept wanted to come up with a solution that could automate the solution. But how do you do this in terms of understanding the living patterns of an individual in their own home without cameras, right? So, nobody wants to live with a camera in their face inside of their home. That's always going to be a big challenge. There's security risks in play of understanding all the parts of your home and what could be deemed as valuable inside of your home. The faces of individuals themselves inside of the home. A lot of ethics regards to this. We had a huge conversation about this, and the big thing that came out of this was, could we do a detection in such a way that doesn't recognize objects or individuals, but recognizes the body mass of an individual inside of the facility itself? What we actually came up with was a solution that used IR sensors. So instead of using optical sensors, we used IR sensors, and the IR sensors was capturing the data of the living habits or the moving habits of that individual inside of the home. So having an understanding of this individual walking through the home, what time they wake up in the morning, what time do they make lunch, breakfast in the morning, what time do they feed their dog or cat, what time do they sit in front of the TV to watch whatever show they're watching. The whole ability to understand what the basic habits of an individual. Obviously there's going to be a slide of 20-30 minutes or maybe even an hour each way. So also building that intelligence. If this individual goes to sleep at 9 o'clock, they wake up at 7 o'clock in the morning. If they go to sleep at 11 o'clock, they wake up at 10 o'clock in the morning. Like that whole capability of understanding of how these individuals are, living their lives. And, should there then be a detection of, hey, you haven't woken up at this specific time, is everything okay? And that notification coming on that individual's mobile device. At any age, mobile device, we're all glued to them. So that notification coming up saying, are you okay? And this individual, pressing yes or no, right? And then if it's a no, that's the sensor that goes back off to their loved ones to say, hey, this individual is in distress, there's a problem. And then obviously if the individual can't get to the mobile device, there's a timeout functionality, which should then notify, those that to respond that there is a problem. The next step to this solution was, what about those individuals that don't have a mobile device? My dad does not have a smartphone, there's no need for a smartphone. He's never dabbled in technology at all. And so how do you make the solution appeasable to them? It was the inclusion, instead of the mobile device, because of the fact that when we build out these solutions, we leave them with open hooks into other APIs. We were actually able to connect this at the time into Cortana. So there was a Harman Kardon device that ran Cortana natively on the device itself. And that became our interface. So when the individual was living up to the patterns that they usually lived up to in terms of waking up in the morning or making breakfast at a certain time or what have you, Cortana would chime in and say, hey, is everything okay? Are you under distress? Is there anything I can do for you? And this individual would then respond back, yes, I need help, or no, I'm okay. Thank you very much for asking. So it was that interface that didn't require an individual to really press anything or even wear anything. It was just a speaker that was in the home that would be connected to have the ability to say yes or no in terms of if they're in distress, and if they are in distress, who should I call for you? Should I call your loved ones, or should I call medical services? Right, having that intelligence to really interact with this individual, learning that, hey, I noticed you haven't gotten up yet. Is everything okay? Are you in distress? What type of support do you need? And that Harman Kardon unit doesn't exist anymore. The evolution of it hasn't come out yet. But when we build out these solutions, as I mentioned, these are all open-based solutions. So now this solution can be hooked onto Alexa. This can be hooked onto Siri. It can be hooked on, in essence, to any digital assistant that's in market right now for the availability of this solution as a platform to help senior citizens in their own home in respect to connectivity and understanding living patterns and addressing distress when it comes up. Pretty cool, Frank, eh?
Yes, it is. It's cool.
How are we doing for time? Are we have a lot of questions online, or?
Question were good. People were asking if, like, we have 3 minutes.
Okay.
People were asking if we can find you also on LinkedIn.
Oh, yes, you can. So definitely find me on LinkedIn as well. You can find me under Anthony Bartolo, or you can find me under Wireless Life. So 3 minutes, so we're good, right on time. Future of computing is your imagination, is your creativity. It's your, what do you want to accomplish? As long as you got the buy-in from those around you inside of your organization in respect to what you're trying to do. And if you're a startup and you have this great idea, make sure you check out the market. Make sure you check out, what's happening in your area in terms of your opportunity and what it will address. It's great if you have come up with this great solution, but if it doesn't address the needs that, people are aware of, it might be some time before it does, pick up and take adoption. Now, with a lot of the things that you saw today, and I know Frank has included the URLs, but I'm going to share them as well. If you want to gain more information in terms of what we've talked about today, docs.microsoft.com is your first stop in terms of all your referenceable material. Here, I've created a specific resource for cognitive services for the demos that we showed to you today, aka.ms/cogservedocs. This will give you a full repertoire of all the cognitive services documentation that's available. Next up, I specifically curated a bunch of learning paths and modules for you to dabble in, including the text analyzer API solution that I've shared, completely free, all sandbox technology, but you're able to take the code snippets into your own Visual Studio Code or coder of choice. In terms of the adoption of said solution, there's the URLs there, and I know Frank has included those as well. And then if you want to get a hold of me, as I mentioned, you can find me on Twitter at Wireless Life. You can also find me at LinkedIn. You can search Wireless Life on LinkedIn. You'll pull up my name as well. If not, you can just search Anthony Bartolo. On the blog, I have the blog alongside my team, which is itopstalk.com. We also have the hashtag that we listed on is AZOps for any questions you have of the team as a whole. And then the GitHub repo for a lot of the solutions that you saw today. Again, available as open source for you to be as creative as you want, aka.ms/wireless life. And that's pretty much everything for the presentation today. Frank, did you have any questions for me?
People were saying thank you for the presentation. I really love the HFM project and the mousetrap project, which can be generalized to many other problems too. But cool. People were very happy all along. I didn't say every thumbs up, but you could rewatch it and read them all by yourself. But no, very positive feedback. People very happy.
Well, if anybody has any other questions, definitely reach out. I know a couple of people have my LinkedIn inbox is growing, so I know some people are asking questions. That's fine. You don't have to ask it on Twitch. You can definitely ask it on any platform that you feel comfortable with. And like I said, have fun with the repo and learn and ask as many questions as you can. I love not being the smartest person in the room. I love learning from Frank and learning from others on my team in terms of how to adopt technology, and never be fearful to speak up and share your creativity and share your part to the solution, right? It's learning is learned best when you share, right? It's not being the know-it-all, it's being the learn-it-all that pushes you forward and enables you to, help others. It's when we take that pause and listen to others in terms of what they're trying to accomplish is where we actually learn at the end of the day.
It was wonderful. I learned a lot today, and I'm happy about that. So thank you a lot, Anthony, for spending this hour and a half with us. And thank you for all of you who spend your time today with us today. And you can come back tomorrow, same time. We'll be with Maxime, and we'll be talking about durable function. Goodbye, everybody. Have a good day.